Hello and welcome to this video on calculating moles. This video, along with the remainder of those published this week, are in preparation for videos coming in the next week or thereabouts, where an amount of chemistry is used to calculate a theory yield and an actual yield of ethanol and other products. Having shown that a mole is an internationally recognized standard, you may wonder how you get the value of a mole. A mole of one element on the periodic table is the same as a molecular weight. This means 1 mole of pure carbon is more than less 12, oxygen 16, and hydrogen 1 gram, respectively. This is true for pure elemental compounds only. But what about paired atoms such as dihydrogen, or pure medical oxygen that is a bonded pair? That is easier. Take the atom and multiply by the respective number of atoms. Therefore, dihydrogen is 2 grams, dioxide is 32 grams, and dicarbon will be 24 grams. But life is not so easy. Di is for twofold, tri is for threefold, and so on. Nearly everything in the world is a mixture of 2 or more different elements. In this case, a mole would not just be the sum of 1 or 2 elements separately, but the weight of all the elements combined. This is best exemplified by glucose in home brewing. To calculate this, the process is simply an extension of the first approach. Start by counting all the elements, in this example of glucose. Many common chemicals have these in lists and tables which are readily available. It has 6 carbon atoms, 12 hydrogen, and 6 oxygen atoms per unit. That means that 1 mole of glucose would be the combined weight of the total number of atoms that make up the glucose molecule. To put it another way, this is 6 times 16 equaling 96, 6 times 12 equaling 72, and 12 times 1 equaling 12. Then the sum of these atoms, which is 180 grams. Do not forget to use units, as these are important at a later point. Now that it is reasonably straightforward, the next part is a little tricky. 1 mole, when it is changed chemically, does not create a half mole necessarily. In ethanol production, glucose breaks down into 2 particular mole sets, one of ethanol and another of carbon dioxide. 2 moles from every one, but it's even more complicated than that again. Glucose breaks down into 2 subunits, which then break down into 1 unit of carbon dioxide and 1 unit of ethanol each. This then leads to 4 moles from the reagents. 1 turns into 4 in this case, 2 moles of ethanol and 2 moles of carbon dioxide. Another way to think of this is that every compound has its own definition of a mole. A mole is the sum of the molecular weight of the component atoms on that side of the equation in that particular compound. When a bigger or different molecule breaks down, transforms or converts, so does the definition of the mole for that formula. This is calculated using a formula like this. On the left is the original components. On the right are the products that are left over once the first pyruvate molecule extracted from the glucose is processed. There is still another one to go, which will lead to twice as many products on the right. Therefore, there should be a remainder of 1 pyruvate molecule that has been missed. There are 2 other approaches to look at this. That is to see how much weight, or in correct terminology, mass has been generated before and after reaction, the mass of initial reagents, and the mass of products. Generally, this is in grams. Another is to use a formula known as Avogadro's constant, although that is for another video. Finally, there is the process discussed initially and so far. That is using a formula and methodology that is then validated via experimentation. This creates a diagram like this triangle, in which you select the 2 known variables to extract the third. You require at least 2 of these: moles, mass, or formula. Clearly, not everything is in whole moles or can be reasonably worked in a whole mole. This is where the real mole exists. It is the mole used in sciences, labs, and even in much of the home brewing if you are looking into technical aspects. So we'll take a weight of sugar, for instance, and put this over the molecular weight for the periodic table. The first is mass of sugar, otherwise known as sucrose, and the second is the relative atomic mass. from the periodic table. Put the weight of sugar over the relative atomic mass. For table sugar, this will be the amount that you have used, over the relative atomic mass of 322 grams. This is where units become important. Weights are often in kilograms, especially where sugars are concerned. Moonshine is regularly listed as using 6 or 8 kilograms, which would then need to be converted by a factor of 1000 to grams. This gives you the number of moles you are using in this particular scenario. Hopefully you now know how to get the number of moles in a product you are using. This product will be known as the reagent, and the outcome of that is called the product, which is rather inappropriately confusing. Thank you for watching. Please post any comments, questions, or suggestions you may have below.